Today we are studying geometric sequences. Our objective is to identify and generate geometric sequences. And we're going to use the graphing calculator for a lot of this, so it's important that you pay attention to the steps so that you can use them tomorrow in class. So in the linear functions unit, we learned about something called an arithmetic sequence. And an arithmetic sequence was just a list of numbers that had a common difference. So you said, oh, well, how do you get from the first number to the second number? You add 2, or you add 4, or you take away 6. And that was the common difference. It graphed as a linear function, and the equation took the form, as you see here circled in red. Remember that a sub 1 was really the first term, and n was the term number, and d was the common difference. So if we were to just refresh ourselves with an example, if we were given 1, 3, 5, 7, 9, well, a sub 1 is our first term, which is just 1. And our common difference, well, how do we get from 1 to 3? We add 2. How do we get from 3 to 5? Add 2. We keep checking just in case, but we're adding 2, and we're adding 2. So my common difference here would be 2. And then I would say, okay, well, a sub n is equal to my first term, which is 1 plus n minus 1 times my common difference, which was 2. And then we'd go ahead and distribute that, and we would make ourselves a linear equation or a linear function. Well, this time we're going to learn about geometric sequences, which differ from arithmetic sequences. A geometric sequence, instead of having a common difference, has a common ratio, and what we're going to look for is a multiplier. We want to find numbers that multiply to get the next term in the sequence. Instead of graphing as a linear function like an arithmetic sequence, geometric sequences graph as exponential functions, and remember, an exponential function looks something like that or like that. And again, we're going to be using our calculator for a lot of this, particularly when we want to generate the equation. However, if you are not very strong with your multiplication and division facts, you're going to want to check all these in your calculator when you go through and do it yourself. So if we were asked to find the next couple of terms in a geometric sequence, our first job is to find the common ratio, r. So we take a look at our first sequence. We're given 1, -4, 16, -64. And the first thing I notice is that the signs are alternating. We go from positive to negative to positive to negative. That means my ratio is going to be a negative number, my common ratio. Well, how do I get from 1 to -4? I multiply by -4. How do I get from -4 to -16? I multiply by -4. 16 to -64, multiply by -4. So my common ratio, since it's the same throughout, is -4. Now if I want to find the next 3 terms in the sequence, I'll do -64 times -4, and that gives us positive 256. And then to find my next term, I'm going to take 256, multiply it by 4. We get 24, 22, we get 1024. That's my next term, but remember this was a negative, so we get negative 1024. And then again, I'm multiplying by -4, so I'll get 16, and this is 8, 9, and this is 0, and this is 4. So -4096. So that's how you would find your next 3 terms. Now if we take a look at our second example, we're given 9, 3, 1, 1/3, and the pattern continues. Again, my job is to figure out the common ratio or a multiplier. So if you're looking from 9 to 3, your first instinct is to say that it's being divided by 3. However, we don't want to talk about division here. We always want to talk about multiplication. And we spoke about this the other day, that dividing by a number is same as multiplying by its reciprocal. So I'm really multiplying by a third to get from 9 to 3. To get from 3 to 1, I'm also multiplying by a third. And to get from 1 to 1/3, I'm also multiplying by a third. So my common ratio is 1/3. So if you say, well, really the only way I can get from the first number to the second number is by dividing, multiply by the reciprocal of the number you're dividing by. And the next three terms, well, 1/3 times a third is 1/9. So that's my next term. And then 1/9 times a third is 1/27. And then my last one, 1/27 times a third is 1 out of 81. And that's how we find our next three terms. So what if you were asked to write the nth term equation? So here it says write an equation for the nth term of the sequence. So we're going to use the calculator for this. We go to our list and spreadsheets page as if we were doing when we completed scatter plots, when we had to type in our data. Your X column or the A column should be the term number. So it's term number 1, term number 2, term number 3, term number 4. The second column is the sequence number. So term number 1 is number 6, term 2 is 12, terms 3 is 24, term 4 is 48. Now if you notice, I took out the negatives when I inserted them into my list and spreadsheets page. So if signs are alternating, take out the sign and just type the number. We'll go back to the negative later, but for now, just take it out, type the numbers as you see them. Again, imagine we were going in to do a linear regression equation. You're going to go to stat calculations, but instead of doing linear regression like we typically do, we're going to come all the way down here to exponential regression. And that is going to give us this pop-up. Remember, we have to tell the calculator what our X lists and Y lists are. So you're just going to click the drop-down list and click the appropriate column. You click OK. And then this particular guy comes right here, just like it did when we were doing the linear regression equations. If you notice, right here, it tells you the equation that you want. A times B to the X power. So here, our equation, if we're going to take A from here, from our chart, A is 3, B is 2, and then to the X power. Now, since I took out the negative signs, I'm going to put them back into my equation. So I'm going to make that 2 negative, and that is my final equation. Please remember to fill out the Google form. Have a good night.